partway through one of the examples. Then I know what I just couldn't read my own handwriting. That was a sad thing. So this is now a 2-day lesson.
Yes.
Alright, so here we go. Angle A is 34.2 degrees. Side B is 19.4. It says applications involving right triangles. Again, you guys do your best to multitask, checking your answers and following the notes. Worst case is you can watch the video again. Example 1 says solve the right triangle shown for all unknown sides and angles. So you do need to fill in what I have in red up here because your handout did not have the givens. Does anybody remember from Algebra 2, what does it mean when a problem asks you to find or to solve the triangle? What's that mean in general?
All the angles and sides.
Yeah, find all the angles and sides that you don't know, okay? That's what it means. So, angle C is 90. Woo! Yeah. Good start. These late starts are killing me. Then to find angle B, you can just either add 90 plus 34.2 and subtract from 180. Or the faster way would be if you know you have a 90-degree angle, take 90 minus 34.2. So the measure of angle B is 55.8 degrees. Please circle or box the things that you're finding. Now we need to find side A and side C. I'm going to start with A. And right now, I'm looking for the opposite side, and I have the adjacent. That's tangent. So we're going to need our SOHCAHTOA. So I have the tangent of 34.2 degrees equals A over 19.4. So if we want to solve this for A, we're going to multiply both sides by 19.4. So this is definitely a calculator problem. Remember to check your mode. The angle is in degrees, so my mode should be in degrees. So let's take out our calculators, check your mode, put it in degree mode if it's not currently, and I'll take 19.4 times the tangent of 34.2, and I'm getting about 13.2. A general rule of thumb is that if the measurements are rounded to the nearest tenths, that's how you'll round your answers. If they're whole numbers and then your outputs are coming out as decimals, then unless the problem states, I'd go one place, maybe two, depending on the situation. All right, now we need to find C. And there's a few different ways to do this. I'm going to show you one and then tell you another one. I want to do it this way just to practice what do you do in this case. So I'm going to use, and when you're doing these, do you understand that A is now a rounded answer? If at all possible, stay away from using rounded numbers, okay? So I'm going to come back to what was given, and I have the adjacent and the hypotenuse. Well, that's cosine, and I'm going to say the cosine of 34.2 degrees equals 19.4 over C. So what I need to do is C is in the denominator. So you actually need to multiply both sides by C to get it out. So I have C times the cosine of 34.2 degrees equals 19.4. So I wanted you to see if your fraction has the variable in the bottom, multiply by the variable to get it out. Then you can divide by cosine 34.2 degrees. So then I got C was about 23.5. Now there was a different way to do this. If you know these two sides in a right triangle, what could we use? Pythagorean theorem. There's nothing wrong with that. I just wanted to show you how do you do it with your fraction with a variable in the denominator, okay? All right, definitions. An angle of elevation is from a horizontal line looking up, but it has to be from a horizontal line, because we kind of messed this up earlier this year. An angle of depression is from a horizontal line looking down. I think what I had seen earlier is we had some kind of a shadow, and you guys were doing this as the angle of depression. Do you see that can't be an angle of depression because it's not from the horizontal. The angle of depression could be here. It's always got to be from a horizontal line, not a vertical. All right, so let's look at some examples. Example 2 says, a safety regulation states that the maximum angle of elevation for a rescue ladder is 72 degrees. If the fire department's longest ladder is 110 feet, what is the maximum safe rescue height? So, let's suppose we have a building. So there's our building. And I have an angle of elevation of 72 degrees. So it's from the horizontal looking up. This is my ladder. It's 110 feet. And I want to know what's the maximum safe rescue height. So let's call that X. And this is vitally important, right? Because if the fire department is called out to a site, they have various ladder lengths, and so I would imagine they're keeping all of them on their truck. But you know, what if they're going to a location and the maximum height that it can go up, they don't have it. So they've got a plan for a different way to try to put out the fire. And you know there's like planes that'll drop water and stuff like that when it gets to be too high up. But we can assume that from the ground in the building is 90 degrees. So from 72, I have the opposite and the hypotenuse. What trig function is that? Sine. So this is the sine of 72 degrees equals x over 110. We should still be in degree mode. So you're just going to multiply by 110. And I got 104.6. Do not forget your units if it's a word problem that has units. Okay? Alright, now let's do that's a very, very basic problem. Let's do one that's more interesting. It says, at a point 200 feet from the base of a building, the angle of elevation to the bottom of a smokestack is 35 degrees, whereas the angle of elevation to the top of the smokestack is 53 degrees. Find the height S of the smokestack alone. So, alright, here's our building. And let's say here's the smokestack. So the angle of elevation to the bottom of the smokestack is 35 degrees. But the angle of elevation to the top of the smokestack is 53 degrees. And we are at a point 200 feet from the base of the building. And we want to find the height of the smokestack. Any ideas? How might we tackle this problem to find S? Any ideas? got one?
Yeah, you could use the, you could find, with tangent, you could find the height of the building first,
Okay.
and then after you find that, you do the height of the other one with the bigger one, and then you subtract whatever the height of the building was.
Right, okay. So here's what we're gonna do. We're gonna first find x, and you do have opposite over adjacent, so he's right, well that's tangent. We're gonna find the height of the building. So you'd multiply by 200, use your calculators. And I got x was 140. Now the next thing we're gonna wanna find, you can't find s right now. You can't say, I can't say it's whatever this distance is opposite over something else, because that's not a right triangle. But what I can do is, what if I call the height of the smokestack with the building y? Then I can say the tangent of 53 degrees is y over 200. Solve that for y. And are you getting around 265.4? Now the smokestack is y minus x. Okay, so do you see how we did that? Your SOHCAHTOA is only working in right triangles, not these slivers of triangles. Alright, let's do another one. Example 4. A swimming pool is 20 meters long and 12 meters wide. Okay, so we know this, looking kind of at the top of it. But then they're asking us to really make a side view. The bottom of the pool is slanted so that the water depth is 1.3 meters at the shallow end and 4 meters at the deep end. Find the angle of depression of the bottom of the pool. So if you're looking at the top, you can't tell anything about depth, right? So we need to now make a side view of this. And so it's 20 meters across this way. It's 1.3 meters deep. And then it goes down to a total of 4 meters. And then here's that angle of depression. It's from the horizontal, where it's parallel at the 1.3 meters going down. So we're trying to find theta. Okay, well this piece is a rectangle, so this is 20. I don't seem to have enough information. This piece is not 4. How long is that? 2.7. This is 2.7. So now I can do it. This is going to be tangent theta equals 2.7 over 20. Now we're going to make a connection to what we've been doing in 4.7. If you want to find an angle, you have to undo the tangent function. And that's the inverse. So you're going to do check your mode, because you would be telling somebody who's going to be constructing the pool, you wouldn't tell them a radian measure. You talk in terms of degrees. So I would do inverse tan of 2.7 over 20. And I'm getting about 7.7 degrees. Alright, now I want you to look at the handout that I gave you. We are going to be talking about bearings, and for some reason students struggle with this, so I myself struggled with it second period. So let's go over this again. I think we had done this last year. Students just do not like bearings. The definition says, in surveying and navigation, a bearing measures the acute angle that a path or line makes with a fixed north-south line. So south 35 degrees east means you go down to the South Pole and you're rotating from the South Pole 35 degrees in the east direction. So then if you look at the examples, the bottom left, north 80 degrees west means from the North Pole, you're rotating 80 degrees towards the west. So it really isn't that bad. And then north 45 degrees east means from the north, you're rotating 45 degrees in the east direction. So then flip it over, there's a back. And it says a boat leaves the dock in Myrtle Beach, South Carolina and heads toward Freeport in the Bahamas at a bearing of south 1.4 degrees east. The boat averages a speed of 20 knots. Now knots are actually nautical miles per hour over the 428 nautical mile trip. So let's try to draw a picture of what's going on. So you're going to have your north, south, your east, and your west. So first of all, let's draw south 1.4 degrees east. So this is actually not very big, but it's from the south rotating 1.4 degrees east. Okay? Does everybody understand how I drew that? Everybody okay? All right, now the first question says, how long will it take the boat to make the trip? I actually don't need the picture at all to answer that question. I know that distance is equal to rate times time. The distance is 428 nautical miles, and I'm going at a rate of 20 knots or 20 nautical miles per hour. So you're going to need your calculators. We'll divide by 20. And I'm getting 21.4 hours. Now the second question, this is where we're going to have to use our pre-calculus. It says, how far east and south is the boat after 12 hours? Okay, I know the direction it's going. It is going 1.4 degrees east of the South Pole marking. And it's traveling at 20 knots or 20 nautical miles per hour. If the boat has gone for 12 hours, what would be the distance? How far is it from the port or wherever it started? 240, right? Because you went 20 knots per hour and you went 12 hours. So it's 20 times 12 is 240. Now the question is, they want to know how far east and how far south have we gone. So they're really asking us to find the x and the y value. Now what's different is they didn't give me the angle inside this triangle. However, this rotation is this angle here. Do you understand that? So if I know that it's 1.4 degrees here, what's this angle? I'm hearing it. What'd you say? 88.6, that's right. Because this is a right angle, right? The east and the east, west, north, south, they make 4 right angles there. Now we can find x using our right triangle trig. I would have adjacent and hypotenuse, so I'm going to do cosine 88.6 degrees equals x over 240. So use your calculators. So I got x is 5.9, and that's nautical miles. And then let's find y. From 88.6 degrees, that's opposite over hypotenuse, so that's sine. And I'm getting y is 239.9. Now think about this. Because when you're doing these, and sometimes, we'll flub up and make mistakes, you've got to see if your answer is reasonable. Okay? So think about it. If you're only going at a 1.4 degree angle off, you did not move very far to the east, did you? But you are going down south pretty far. And doesn't that make sense if you're going from Myrtle Beach down to the Bahamas? You don't need to go out that far, but you're certainly going south a greater distance. Does that make sense? Okay. All right, now we're going to start this next one. This is the one that I flubbed up on earlier, so let's see if I can't do a better job. I just couldn't read my own handwriting was my problem. All right, in example 5, it says a ship leaves port at noon and heads due west at 20 knots or 20 nautical miles per hour. At 2 p.m., the ship changes course to north 54 degrees west. Find the ship's bearing and distance from the port of departure at 3 p.m. All right, I'm going to try and make it bigger so I don't have as bad a problem here. Okay, so here's my north, south, east, and west. And I'm going to change colors so I can see things a little better. All right, so the ship leaves port at noon and heads due west for 20 knots or nautical miles per hour, and they go for 2 hours. So what would the distance be in 2 hours? 40. Okay, now, wherever you stop, you have to imagine another north, south, east, west pole there. Now, the ship is going to change course and go 54 degrees west of the North Pole. Okay? And it only went for 1 hour. So this is just a distance of 20 nautical miles. And what we want to know is find the ship's bearing and distance from the port of departure. So I really want to know from the point of departure, how far is it? So I would need to know this distance of the triangle. And I also to know, like from north, how far west would they need to turn to get to that spot. Okay? So let's draw this triangle separately, okay? So this is 40, this is 20. All right, the other thing I know is this angle right here is 54 degrees, and this is 90, right? So what's this angle here? You know what this one would be? 144? Yeah, 144. But then what I want to do is I want to drop a perpendicular here. Because if I can create a right triangle, I can end up finding the hypotenuse here. Okay, now you can't do Pythagorean theorem on triangles that aren't right triangles. So in this one, let me hang on my paper. So let's call this height A and this one B. What would this angle be down here? 36 degrees. Okay, well can't we find A? Because from A I have the opposite and I have the hypotenuse. So that's sine, so I'll do the sine of 36 degrees equals A over 20. So go ahead and multiply both sides by 20. So I'm getting A is 11.8. And then can't we find B? Then I can do Pythagorean theorem if I can get this piece to know the whole thing. So that's cosine 36 degrees is b over 20. So I got b is 16.2. So then let's do the whole big thing. This would be, what, 11.8 squared plus, wouldn't that be 56.2 squared equals, and maybe we'll call that c. And let's do Pythagorean theorem on it. And I'm getting about 57.4. Now that's how far you are from the port. So we're 57.4 nautical miles from port. Then we want to know the bearings. So in my triangle, I can find this angle now, right? I have enough tools to figure out this. Then I actually need this angle here, okay? So, I don't know, what do you want to call it? We'll call this angle A. So I have the opposite, well, we'll finish that very last one, okay?